Hello, everyone. Welcome to the latest edition of the DePINed podcast. I'm your host, Tom Trowbridge. Thrilled to be here with Neil, who is the CEO and co-founder of Dawn. And Dawn is building a decentralized broadband platform. Welcome, Neil.
Tom, thanks for having me on here, man. I really appreciate being given the time and glad we got bumped into each other and glad we found our way here.
Yeah, definitely. Well, I think it's not a huge world. So eventually you go to a couple conferences, you're going to bump into everybody eventually, I think. And that may change, but right now we can still do that.
Yeah, indeed. And it's kind of cool to see this small cohort of DePIN folks continue to grow, build out new projects. So yeah, as you said, I guess we've been bumping into each other for a while now, so good to finally be connected.
Well, definitely. Listen, I'd like to start by asking people to define DePIN. So how would you define it?
Yeah, so I think a little bit more of like a Web 2 type definition for it, but I know that there is stuff that falls out of this category, and I haven't been able to figure out how to kind of capture the other stuff. But my kind of canonical way of defining DePIN is I just think of it at the top level as decentralized cloud and decentralized telecom. And in my mind, those are really the two prongs of the internet as we know it, right? It's everything you need to service the content that people engage with and everything you need to actually deliver that to their home, right? The cloud and the telecom piece side of stuff. So anything time you have a user powered element that fits into that, whether it's decentralized cloud service or decentralized telecom, I squarely put those into the DePIN category. But as things have kind of expanded, there's this extra subset of stuff like there's DGen, right? Decentralized power generation. And you have stuff like, daylight, for example, operating there. And then you also have stuff on the demo side of stuff. So I haven't necessarily figured out a very clean way to put those guys into one bucket that jives with my overall definition. But my heart is a little bit closer towards the cloud and telecom side of stuff. So I very much so kind of lean towards those for my definition. And then the stuff that's, falls outside of that, but is clearly DePIN, I kind of, tuck those in there one way or another. I can't say I've got a quick rule for that, but hopefully it's fully self.
Fair enough. I mean, tell me if this definition works for you. Crowdsourced infrastructure that is put together in one network that's incented and secured by crypto economics.
Yeah, I think that it's a definition that works, but the more that I kind of you kind of get to those sorts of higher level definitions, you start having to ask yourself I know Melton likes to mention this. Bitcoin is a DePIN.
Yes,
right?
DePIN. No, you have to exclude block production, and maybe I would put into that provides a service, and I would argue that like a service people pay for. And you don't, and block production doesn't really count as a service. I would say that's how you'd add a little addendum, I suppose.
Agree, and that I think is the right addendum. Like once you start thinking about like a digital service to some extent, or some sort of infrastructure enabled service,
exactly,
that is consumer powered with some level of a hardware component. I think that's when we start getting into like a good definition.
All right, we'll adjust the definition accordingly. So tell us about Dawn. Give us the overview and then the detail.
Yeah, so what you kind of mentioned from before is like the best tagline that I can go with, right? Dawn is a protocol for providing decentralized broadband. And the idea of it's pretty simple, right? Today, you buy your internet from one of the big monopolies or duopolies in your local region. But we are painting a world where you are not buying that from them. You're buying it from a community, a decentralized cohort of people that have excess bandwidth to be able to offer you, and you're buying it directly from them. So think about it as essentially a user-powered mesh network that is focused on delivering high performance. So something that can compete against the local fiber options if you're lucky to have fiber. But really kind of the threshold is at a multi-gigabit level service. So it's essentially decentralized broadband with an aim at delivering gigabit plus level services. And the easiest mental model that I always give to folks here is the same way that Helium provides decentralized mobile service. What Dawn provides is decentralized fixed services, right? So fixed, typically broadband, so internet for homes and for businesses. And our kind of vision for all of this is how can we use a consumer-powered wireless network to really just make internet cheaper and more accessible to everyone. So there's a lot of fun elements we can get into there, but hopefully that serves as a good high level.
Well, yeah. So help us dig a little deeper into that. So you mentioned fixed wireless. So is this, are people buying antennas and then both transmitting and receiving signals over how much territory does one antenna cover? Like, help us unpack some of the details and how this works.
Yeah, so exactly as you said, it's a category of fixed wireless, right, versus mobile wireless where the endpoints move. In the fixed wireless scenario, the endpoints are not moving. So in this scenario, yeah, it is a multi-gigabit fixed wireless network where the underlying range of these things is, in the range of 3 to 4 miles, probably the max. You technically can go further if you're willing to sacrifice speed, but if you're trying to get squarely into the gigabit range, 3 to 4 miles is the range that we're working with. And so then the idea is that anybody all across the world that can host an individual node can share their internet connection in a pretty wide range. And then all it takes is somebody on the receiving end to get their own fixed wireless connection that then allows them to be able to tap into that. And so our focus is really building the protocol and the technology that allows this stuff to be able to propagate far and wide, and make it very easy for people to be able to get up and running with this sort of approach. Because, we at, Andrena is the company that has created Dawn. We are a wireless internet service provider operating in 10, just about to be 11 states now. And through this entire process of being our own fixed wireless operator, we've taken a lot of the technology that we've built that has helped automate various aspects of internet delivery, and now we're making it accessible for the consumer to be able to grow the network with us. So it's essentially saying, hey, how can we allow folks all across the world to build mini Andrenas when all you need is a little, just a single home, and that's enough to be able to provide a meaningful amount of service. Yeah. So to answer your question, it all comes down to fixed wireless technology, dishes on top of roofs, but also just a little transmitter in your home is enough to be able to participate in the network as well.
And so, help me understand then, if I put an antenna up on my roof, then anyone within a couple miles can access that. I can share my bandwidth and effectively get paid for doing so. And then is there a redundancy as well? So if two people do it, if I go down, someone else can hop to the next person, or it's split. Is that how it works?
Exactly, right? And the goal here is like redundancy is king in wireless networks, right? Because you have to deal with a myriad of issues like power outages and stuff. Maybe over several years, trees will grow and block your line of sight. So you definitely want to have a good redundant network that gives you, multi-homing is what they call it. So you have multiple different paths out to the internet. And we see this as like a huge advantage, not just from like a raw infrastructure redundancy perspective, but also from like a price convergence perspective, because our goal is like, how do we bring cheap internet into people's homes? And competition and more options for connectivity is really the way to go about doing that. And so if I can kind of like find a way to kind of summarize the vision in a little bit of financial sense here, it's like, I'm calling you and we're recording this podcast on my Verizon internet connection, right? That Verizon connection on my bill is $128 per month, but that same volume of data costs Verizon like 50 cents. Right. So what's really stopping people from getting access to internet that's cheap? And it ultimately comes down to both cheaper infrastructure for one, which is where wireless comes in, and a lot of the stuff that Dawn helped build to automate that wireless delivery. But then the second piece of that is just having more competition, having more people that are offering that service, both from a redundancy standpoint, but also bring the price lower. Because my real goal is I just want to bring wholesale internet prices to the retail market. There's no reason it needs to be as expensive as it currently is. And with wireless and more nodes being able to provide service, it can really get much cheaper.
And so in order to share your wireless, I would need to have a receiver that I need to install in my house or apartment or window or something.
Correct. Either something that you can just put in like next by your window, by a wall, or something on top of your roof. There's many different ways to really be able to leverage a connection. It depends on what's available in your neighborhood. The easiest kind of example I give is like in an ideal scenario, it's like think about this as like a Starlink type connection, right? The same way that you put a Starlink antenna on top of your roof and that points up and connects to a constellation of LEO sats. This is very similar, except instead of pointing to a constellation of LEO sats, it's pointing to somebody else in your neighborhood that has excess connectivity.
Excellent. And that will then, and then do I choose how much I am charging for my excess internet, or I put up a price for that?
Exactly, right. And so that's like in a scenario where like if I am paying $128, but this recording is only using like what half a 0.5% of the supply, 5 megs out of the total gig, I have so much extra that, you could do whatever you want with it, right? And that's what we're finding, like, is the FCC's stat for like average internet usage is only 1 megabit per second per household. So in the last mile, whether you're talking directly about retail or on the wholesale side, and we can talk more about wholesale side, there's just so much excess. And so, yeah, you can be in a scenario where say, hey, let me just sell my internet for $30, and people are going to save 50 all the way to even $100 on their internet bill in the surrounding area. So, yeah, and we very much so want to create this like peer-to-peer type approach where we don't really have a centralized provider operating on the system. It's everybody is setting their local rates for how much they want to charge for their excess bandwidth in a given area.
And am I selling it to multiple people at the same time?
Absolutely, yeah. That's kind of one of the key unlocks here. Is like, if you want to do a network like this, which is essentially just a community-powered wireless network to replace the internet monopolies, 2023 and really more like 2024 were the first years where this technology is possible because of this one category of fixed wireless called point-to-multipoint, multi-gigabit. And what that really means is that one node can talk to many other nodes at the same time with a multi-gigabit capacity. So to answer your question, yeah, you can be selling it to multiple different people. And it is really all enabled by the fact that wireless has just finally caught up to being able to offer performance with the level of scale that you need to be able to achieve that result of a user-powered multi-gigabit network.
Well, I want to talk about what the companies do, but before that, this gets sort of short circuits to or shortcuts to a question I have a little bit later, but I'm going to get into it right now. A bunch of DePINed projects. Helium is kind of poster for this. I think Kyle Samani, I was talking to him probably 6 months ago, and he mentioned that the original Helium prototype cost like $1,000 or a couple $1,000. Then one particular chip went off patent, and they were able then to drop the price to, the initial one was probably $500 and is now down to whatever, 200-300. And so you effectively had technological / IP developments that without which Helium couldn't exist. And I think that's true for multiple projects, right? Like Demo, we wouldn't be able to build those cameras at scale cheaply 5 years ago. Sounds like there's a similar technological kind of prerequisite for your solution to exist, and that Dawn couldn't have existed, you tell me, 2 years ago, 3 years ago. And it's a confluence, obviously, of crypto economics, but also real hardware and advancement. Is that fair?
That's very accurate, right? Like when I first started Andrena, building the wireless network with Princeton University in 2017, like I wrote an article about how fixed wireless and blockchain can solve this massive problem. But I didn't end up going down that route because I knew that the wireless technology wasn't good enough to be able to operate at the scale where it could really be done by a consumer. And so that's absolutely the case. And I'd say there's 3 major categories of hardware that have been an unlock, and we have contributed towards the development in various different ways. One of them, as we discussed, is like that point-to-multipoint, multi-gigabit wireless, right? Like if you want to build a consumer-powered network and get massive consumer adoption, the service has to be as good or preferably better than the existing fiber options that are out there. And 2023, 2024 were really the first 2 years where that became actually possible to be able to achieve. So that's kind of like the first unlock. And we have taken it a step further by taking that technology and building what we call the ROS, which is a robotic antenna system. It's essentially a way in which those antennas can actually automatically align themselves to be able to tap into that signal source. So to the previous argument you made when we were talking about how does redundancy fit into this, if you want to have a wireless antenna that is high performance, they need to be directional. But if you want to adjust to that network because a new cheaper source of connectivity comes up, you don't want to be in a scenario where you got to go on your roof or touch your dish, right? So that's why we built that robotic antenna system that actually moves the antenna to point itself wherever that signal source is. So that's an example of something that we have saying is like the wireless is good enough. Now let us go the next leg up and actually begin to automate it so that you can actually really just automate this entire process. So it can be easier for the consumer, but it can also have self-healing properties, which I think is going to be really important for these sorts of networks. The second major category that we focused on, which allows us to operate in like close range, high performance scenarios, is we actually went down the route of manufacturing our own Wi-Fi access points. Not one that you kind of typically find here, but then to a similar type of chip argument is thanks to all of the developers that have taken like MediaTek and Qualcomm chips. It's been very easy to get reference designs for these Wi-Fi boards and start manufacturing your own. The point being is like we now produce as a result probably the cheapest enterprise Wi-Fi system in the world. So once you actually get that connection with your robotic antenna system, you can actually propagate that to your neighbors, to your neighborhood in a very cheap way. So that's another major unlock that allows us to kind of do this in a really cost effective way. And then the third and final piece, which is I think a fun one to talk about because it has more implications beyond the networking side of stuff, is we actually built a high performance router that operates all in software. And that is thanks to technology that was open sourced by Cisco in 2021 called VPP. It essentially just allows you to take a generic computer and turn it into a high performance router, which, typically if you want to get that same level of performance, you have to go buy something expensive from Juniper or Cisco. But the fact that now like a generic box can do this is another major unlock here. And that comes with a lot of implications that we got to talk about down in a second on the compute side of stuff. But the overall theme, as you kind of pointed out from like both the Helium side or the Demo side, is infrastructure is so driven by cost, whether it's on the CapEx or the OpEx side of stuff, that I think the real kind of stepping functions for these new types of technologies to emerge come when you have that massive reduction in CapEx, but then preferably when you also have a way for the OpEx piece to either be fully automated or partially automated. So that I think is a big part of this equation. So everything from the wireless side, being able to reduce the CapEx, the robotic antenna system to be able to reduce the OpEx, all the way from the software router and then the Wi-Fi systems to also reduce CapEx. Those have all been major unlocks that have made this possible, both from a performance standpoint, but then ultimately in a unit economic standpoint as well.
Super interesting. Dev, well, let's back up for a second and talk about Neil and how you mentioned looking at this back years ago. So it sounds like you're sort of purpose built for this type of role and this type of launch as well. Is that the case?
I mean, it depends who you ask. I did like it's funny because I remember being in a high school and like learning about random technology verticals, right? And like one of the ones that I encountered was like telecom. I'm like, wow, telecom sounds so boring. Who the hell would do this sort of stuff? So that there's like when I think about my experience in telecom, that's really how I got started. Is just thinking it's a boring sector. But to kind of back up into, I guess, how we got to where we are here is like, I was Princeton class of 2015. I dropped out in 2014. I still live in Princeton because we do a lot of work here. But I know my background was electrical engineering and robotics. So I ended up, straying away a little bit from that to go work in as a VP of engineering at a software analytics company or a healthcare analytics company, just building an expensive SaaS platform. And eventually I got kind of tired of that whole approach and I wanted to go build technology that was a little bit more impactful in the everyday household. And so after building a close range data sharing app, that was really when I first started falling in love with this idea of how can people team up together to solve big technology problems. And connectivity in my mind was the most obvious one, right? Like everybody who gets into wireless networking RF, one way or another, whether you're a researcher, whether you're an operator, you're kind of enamored by this idea of how can people team up together to solve large scale connectivity problems. And that was one that, again, I fell in love with super quick. And as I got massive inspiration from like community powered mesh networks like WiFiNet, the biggest in the world, that started off in Catalonia, Spain, and now goes off to Portugal and other areas. Like this idea of people coming together and using wireless to cover these holes, there's just been such a long track record of this. And so to be able to play now my part in trying to bring that vision home with a real scalable and solution that is paired with a great product offering, I think it's been, I hope this is kind of it's been an honor of my career so far. So I'd say the background that I've got from like, electrical engineering and robotics has segued quite nicely into what we're building now. But then all of the networking stuff, I've had to pick that up on the fly. And I've got a bunch of great mentors that have been, a huge help in all of this. So get back to the question, am I tailor made for something like this? I guess we'll find out sometime soon, right?
Fair enough. Well, definitely got some core, expertise that's very relevant. You mentioned robotics and obviously electrical engineering. Both are super important when you're dealing with hardware, and that's obviously what you guys have to understand very well versus the more generic cloud stuff where Fluence, we don't touch like the hardware is generic bit, right? It's CPUs, it's GPUs. We don't have to understand anything about except how many cores there are and what they're used for. You've got a lot more to deal with on the hardware side than we do, and then the storage providers do as well, for that matter. Um, one area you didn't study, I think, but you probably have to become pretty familiar with, though, is crypto economics. So can you talk about the economics and how those work? What do people buy? How do they charge? Where does, because what you're basically set up is a system that sounds like it could work without crypto economics, right? That seems to be, it'd be cumbersome, right? How would you charge people? How would they pay? Would you have to set up a credit card? Like, sounds like a headache. But I'm guessing crypto makes it much easier, and love to hear kind of how that all works.
Yeah, that's kind of, I think, the one thing I want listeners to kind of keep in mind here is like this entire nature of essentially arbitraging internet to turn internet into a proper commodity. You technically don't need crypto to be able to achieve that problem, right? You're just taking people that have excess and matching them up with potential buyers in the system. And you bring up a great point. It's like, where does really crypto come into it? And I think crypto comes in to really take that model and, as you said, take it to the next level from both like a convenience standpoint, but also from an incentive standpoint, right? Like if you're in a scenario where you can buy a $200 box, which in this scenario, we're going to have boxes that can be that cheap, and you can resell your internet to your neighbor for $30, you are going to get your payback in less than 7 months, right? Like you don't need a token to be able to go out and provide that level of incentive. But I also think that's what makes it so powerful, because almost every other DePIN project that's out there has to incentivize people to buy the hardware. And then through some level of token emissions, the user is finding a way to be able to recoup their investment on their underlying hardware. But here, users don't have to recoup their investment with tokens. And I think that's one of the really powerful things about what we're building is there is this constant influx of demand because everybody's buying a monthly internet subscription. So there is these ways to recoup your investment that are kind of embedded directly at the low level. So then now to kind of take that to where the real token comes in, the token comes in from a lot of different directions. One is, as good as that concrete ROI is, to be able to have some level of emissions on the protocol always helps drive the incentive home really far, right? And so as you're thinking about like a go-to-market for bringing something like this to the world, crypto has proven to be such a great way to build supply that I think it would be a little silly to not pay attention to that. So from a simple standpoint, there is this idea that tokens are absolutely the best accelerant at a protocol level to be able to bring a protocol to anybody worldwide, or to be able to bring this technology to anybody worldwide. So at a simple level, it's essentially all of the usual DePIN rationale for why do you use a token. But I think we can kind of go the next level when you combine the fact that there is a non-speculative return to the individual user, and then tokens just hopefully help accelerate it further. The next piece towards this is like where a real token comes into all of this is this idea that in order to make a proper trustless network, you need to have some level of stakes that are involved in it. You need to have, whether it's some level of staking or slashing with these rewards tied into it. That's really an important piece of where this comes in. So in this type of scenario, when you are looking to provide bandwidth to everybody, and you say, hey, I'm going to sell a gigabit to my neighbor, for example, how do you really know that you have a gigabit to be able to sell to your neighbor? And that is where you have certain proofs that we have built in cooperation with the witness chain team to be able to actually provide those proofs tied to a level of crypto economic security. And so in this scenario, Tom, if I'm selling you a gigabit of service, you don't really know if you have a gigabit, right? Like your best course of action is to just go do a speed test and then call and complain. But if you can provide a trustless way to do a speed test where there is no arguing about what your underlying speed is, then you can start doing interesting things like having a programmatic or a decentralized SLA, where if you're not getting your full gigabit, you're going to get your refund automatically with or without you even having to complain. And I think these are sort of the things that crypto allows you to do, is it allows you to add this entire trustless layer, which is what you need to be able to grow something like this really quickly and allow people to transact with each other without having to worry about this entire centralized system that operates on top of that. And there's a lot of other interesting mechanics that crypto gives you the ability to do. Like when it comes to actually providing coverage in an area, we're going to be giving people the ability to access exclusive spectrum that you access through staking, right? Not something that you can really do without crypto, without having to put up some capital. But something like this allows people to get started with the system very easily and then take their node operator to the next level by getting exclusive frequency that allows them to kind of have a good spectrum control over an individual area. So I'd say it's really kind of recap here. It's number one, it's all the typical DePIN incentives that crypto offers. But then the second piece, it's really that entire trustless coordination layer you need to be able to rapidly take this worldwide without having any central authority on this.
I mean, and so a lot of different places to go there, because what you're combining is what I would say is more of the institutional cloud level token uses in terms of trust and in terms of SLAs, in terms of that, which I've really only seen on commodity cloud like hardware where it's important. Like you don't see staking for more retail oriented applications and uses because usually that hardware is provided and the chance of it being forged is not so high. So you're combining both, which is pretty interesting because you're putting what it sounds like using crypto to enable um, institutional level trust on retail run hardware.
Exactly, right. And I think that's been the big challenge of like, why didn't I originally go down this route, in 2017? Ultimately, the wireless hardware wasn't good, but then I wasn't clear on how to actually build this trustless layer. And thanks to a lot of different proof points, some you get from Helium, but other proof points that have come from these various proofs that, like proof of bandwidth, for example, that are relatively recent, the underlying mechanisms for building these didn't really exist back then. But then to your point, that's exactly it. It's this entire trustless layer that is brought down to the retail level using some of these, higher level principles like staking and all that kind of stuff. So absolutely. And there's other interesting dynamics that we can kind of talk about on like what the token allows us to do. But Tom, I know it seemed like you had a question there. So
well, yeah, I mean, just curious to get into exactly more detail. Like, what is it all determined? Can you tell me how the rewards work? What staking is required? Like, how I buy a box for an antenna for $200. What's the next step? I buy a receiver for what? Like, help me understand kind of the bits and the different pieces and how the token plays into that.
Yeah, so the first level, easiest way for understand is my belief when you kind of, and I think everybody kind of believes this one way or another, but how people implement it changes. You want to have the protocol emit rewards in a way where the value of the supply or the tokens are essentially proportional to the value of the supply. And so a key element of our system is based on where your node is deployed, the protocol is going to reward operators proportional to how many households are covered with the creation of that node or the coverage of that.
And just as a question, does that mean unique or not? So if I'm the 10th, am I rewarded just as much as I'm the first in the same coverage?
Yeah, it is not unique. So it's because to your point, redundancy is going to be a very important part of the system. So we want to essentially prioritize redundancy and density early on. So we don't necessarily want it to be unique. We want it to be allowing anybody to be able to incentivize anybody to create multiple options, converge the prices down while providing redundant options there. So that's exactly it. And, we have to go through the math, but for simple kind of, thinking on this conversation, it's imagining you provide, you deploy a node and you get, for example, 1 token per month per household. And that way you are kind of rewarding people proportional to the exact value that they're creating on the system.
And per household served or per household covered?
Just per household covered, Fair. Right? And, okay. Don't hold me on the exact number.
No, but fine, just ballpark, yeah.
A ballpark example about what that looks like, right? And that comes towards like traditional TMT analysis, like the major metric that a lot of internet service providers look at, or like tout, for example, is households passed. And a household passing is what they call it, is like just my ability to service people. And so what essentially the protocol gives us an opportunity to create a community-powered network that achieves a lot of passings. And so what we want to do is reward people proportional to the amount of passings that they contribute here. So that's the first one piece of it. The second piece of that is just by having excess bandwidth on the system, and we call that seeding the network with bandwidth, you're going to get rewarded to that proportional to how much bandwidth you can contribute on that as well. So you can kind of see this recurring theme as like the two most important elements for us to be able to incentivize are going to be wireless coverage and excess bandwidth. There's more kind of other interesting things that are there, but hopefully that kind of covers the first high level example of what that looks like. And then going towards, the next side of stuff is, okay, I've provided the coverage. What happened? I've provided the coverage. I've got the supply. What happens next? So what happens next is, depending on sort of the node that you want to do, anywhere from, $200 if you want to go, provide a massive amount of coverage in a very high density environment. You can pay, anywhere from $1,000 to $2,000 for like a rooftop node, and you can serve hundreds of different endpoints that way. In that type of scenario, you're essentially going to have your excess bandwidth, and you're going to be using a mobile app that interacts with a protocol to create what's called a bandwidth contract. When you create that bandwidth contract, you essentially set your rate and say, okay, I'm going to offer a gigabit for $30 in equivalent of what the Dawn tokens will be. So it might be $30 in fiat because everything in the market is priced on local fiat, but the conversion happens behind the scenes where people are actually paying in the tokens. And from that point on, you'll be able to set that plan. Other people will be able to buy hardware that will get shipped directly to them and will automatically tap into your wireless network. And then from that point on, you have the option of, at the end of the month, do I want to hold these tokens? Do I want to sell these tokens? Whatever you really want to do. But it's one way in which you're essentially creating this, community-powered supply. And then you pair that with people that are ultimately looking to get cheaper internet that way. So that's, I'd say, the first real example of like a simplified type of flow. There's other levers that go towards and kind of help accelerate this. But Tom, I'll kick it back to you. Any questions there that you think are worth diving deeper in before we get to some of the more complicated stuff?
Well, this is terrific. And I think the one piece that I think you've mentioned, which I think is really important, is that it sounds like pricing is in fiat and people pay in fiat, but there's token on the back end. And that is interesting because, there are clearly people that I hope you figure that out. They're taking some people who've spent a lot of time trying to figure out how to do that, because you don't want any any friction for adoption. And that if it had to set up a wallet, blah, 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 be tough. So that's great. I guess the next part you're probably going to is where the staking comes in, because we haven't talked about that yet.
Correct. Yeah. And the way that the staking comes in is part of what makes this whole thing possible is not only that the wireless technology has got good enough, but there has been a bunch of frequency that has been released for operators to be able to go do a whole bunch of stuff with. And the two most notable bands where the Dawn protocol is going to be operating is on the 6 gigahertz side of stuff and the 60 gigahertz side of stuff. So what I think is kind of important to consider is like the last time this much spectrum was released led to the creation of Wi-Fi and Bluetooth themselves. So we are at this unique moment in time where not only do we have the technology that can be perform enough, we also have the airwaves available at our disposal to be able to actually build really cool solutions with. And one of the things that's a very important belief of the system is we need to take care of that resource and avoid a tragedy of the commons type scenario. And the best way to kind of see that tragedy of the commons type scenario is like look at the 2.4 gig spectrum and Wi-Fi. Right, the 2.4 gig spectrum and Wi-Fi is like primo spectrum, right? Like T-Mobile has their B-band 2.5 gig spectrum, which has been absolutely essential for them to be able to provide 5G service on their network. And 2.4 is a little bit below that, and that's where all of Wi-Fi essentially got its real adoption in Bluetooth as well. But there's so much congestion on that space that it's ultimately become kind of a not really good spectrum to use anymore if you want to focus on performance. Still pretty good for reach, but not really as performant as it ought to be. And that's because there is no coordination layer for how spectrum is allocated here. So anybody just grabs whatever they want. And so one of our core beliefs here is with the 6 and 60 gigahertz spectrum, those have real monetary value associated with them. And to avoid the scenario where everybody's stepping on each other's toes, the protocol has a way that allows the coordination of these. And so essentially what happens is that if you're a node operator in, say, New York, Brooklyn, wherever it is, and you want to be able to provide coverage in a given area, you're going to essentially be able to enter a round robin pool where frequency is allocated for you, where you don't have to stake. So essentially, if you want to get involved in an early way without having to worry about staking or anything like that, there's a specific chunk of the frequency that is reserved for a first come first basis and then handed out depending on density and all that stuff based on whoever is in that area. That essentially is like a low friction way of getting started. But if you're then saying, hey, I've got a bunch of rewards from providing internet service in my area, how do I take this to the next level? You can actually take your rewards and stake them to get exclusive access to a new frequency band. And when you get access to that new frequency band, that's something that in an even larger radius, nobody's going to be able to step on. So you essentially have clean airwaves the same way that Verizon and T-Mobile have clean airwaves so that you can provide a high quality service. So it's essentially kind of saying if you want to take your service offering to the next level and stake for really great service, this is a good way to be able to do that and lock that frequency. And the easiest analogy towards this is the same way that the FCC auctions spectrum towards T-Mobile, Verizon, AT&T, and Dish. But rather than having to do it with an auction type approach, we're using a staking type of approach where if you are not abiding towards that, your rewards will actually get slashed or your stake will actually get slashed in that type of scenario. And so it's essentially saying frequency's got some monetary value. Let us find a way to have a mechanism for people to be able to get access to that without stepping on each other's toes and having some penalty if people don't abide by how they're supposed to use it.
And that staking allows the operator, the provider, whatever your terminology is, to charge more or have...
It allows them to provide better service. That's the kind of key thing. So if they want to use that better service to charge more, they totally can. But our major focus on that is that it allows you to provide better service at a longer distance.
But the only reason you'd care about better service is if you were paid more.
Or you could be able to just scoop up market share, right? Like it's not necessarily as straightforward as being able to charge more. Is that if you can have better service at a longer range, you can just scoop up more market share.
I mean, you get people to switch to you effectively.
Correct.
You have to let people know that, though, which means you're marketing, and you're marketing to a very small community. So that's sort of door-to-door marketing, more or less, I'm guessing, or hyper-targeted ads. I'm not even sure.
Yeah, it depends, right? I think that's kind of part of the challenge that we have to figure out on the foundation side of stuff is how do we drive user interest for internet wherever it is towards essentially like this broadband marketplace. And what we're currently building is like a map where you can see where are all of these nodes located and what are the various service offerings you can see and which ones would be kind of more of the premium type service offerings, which would be able to provide a higher level of SLA, higher level of quality, all that kind of stuff. So absolutely. And that's part of the challenge that we have to solve here.
And staking, to do that, what magnitude of stake are we thinking about requiring, or how do you quantify that?
Yeah, because it's very localized, we're anticipating that from the concept of like raw fiat dollars, it's probably never going to be more than a couple $100 at the most. We're anticipating that the prices are going to change with some level of a bonding curve based on density, but we want it to be very accessible for people to be able to do this. And I think it's kind of one of these interesting things is that as these, as the access to spectrum gets slowly gobbled up, we can very much so see a scenario where people start selling their rights on the spectrum bands to other people that want to operate in this area. So we want to keep the barrier to entry very low, but we can totally see a scenario where a secondary economy forms for spectrum.
So two interesting things there. So you effectively would get an NFT or EV3's talk about medallion for your spectrum that's tradable once you've staked it, and that sort of allows you to monetize your stake effectively, or even borrow or trade it. That I think is a whole other concept by itself, which is fascinating because this is doing it at a pretty small scale versus a daylight's doing it on a larger scale. But I think it's that is super interesting. But the other point that you mentioned, which you sort of didn't even acknowledge, is that you priced that stake in dollars, and it wasn't just a token bit. And I think that's super important and really interesting. And that's Fluence is all about stake being in dollars and also rewards being in dollars, but paid in the Fluence token. Because the problem for you in particular versus a Filecoin miner is if it takes 10 tokens and the tokens are $1, great. The tokens are $1,000, nobody's going to stake it, right? So you got to do a fiat element because your customer base is going to be price sensitive and they're not going to be able to afford the token spike if that happens, right? And people always focused on, token price goes down, the rewards aren't worth anything. But the problem also is token price goes up, and what happens to network use, utility, adoption, et cetera, if you have a high token price. It sounds like that's something you're attempting to solve for by making that price in fiat.
Totally, right? And that's I think that's ultimately what more crypto projects need to do, right? Like a token is just a means to an end to help facilitate various types of exchanges and to help accelerate your platform. But at the end of the day, we can never lose sight of the fact that we're just appealing to end consumers, right? Like the example that I always think about is like when we're building the solution and the tokenomics to some extent, like okay, is this something that my grandma who lives in Jersey City can interact with, right? Like that's the barometer that we have to use when trying to focus on how do we bring what we have towards a massive audience here. So I couldn't agree more.
I have two comments. A, of course, agree with that. And the second point is I also think token economics should be able to be fully explained on one page. And if they're not, then it's too complicated. And right, that is, and there's, examples of one of the very first DePINed projects where literally I couldn't find anyone of the hundreds of people in the project that could actually understand it. Only the founder did, and he was really trying to create a whole new economy like Bitcoin. And I just feel that is a very difficult path to go down.
Agreed. Yeah, I think it's funny because like coming from somebody like I was relatively late towards the crypto economic incentives and how to really think about them. So, with my kind of lack of understanding versus all of you guys were a little bit deeper in it before I had to take simple principles, to try to understand what is really worth incentivizing, what is really worth having the protocol incentivize, what are the sorts of consequences you need to have in the system, why do they make sense? And I think those kind of simple fundamentals as like your driving points for their protocol, I think are obviously the most important ones. And I think as long as people kind of stick towards that sort of thinking, hopefully life gets a little bit easier. And then to your point, yeah, it needs to be described on a single piece of paper. Like if you could have 15, 20 bullet points to really explain your tokenomics, then I think you're doing something a little bit more right.
Well, agreed. I mean, listen, your approach to this is very Web 2 with the token element
Yeah,
as opposed to token first, figure everything else out around it. And I think that's, and my thesis, for whatever it's worth, is also that this DePIN sector is going to attract, is going to get revenue and traction before most other crypto does. That's going to attract investors who are more traditional investors, and those investors are going to be much less forgiving about opaque, complex, or non, clearly linked token models. And so that is the sort of crypto native fudging is not going to work for the investor base that I feel is going to be coming to DePIN as DePIN scales with revenue. That's my thesis.
I agree. And I think that's where like, we kind of briefly mentioned it, like concepts like the medallion system are going to be, in my mind, like some of the ways in which DePIN can actually start attracting some institutional capital to really help further the protocol. So I guess we probably should talk about the sort of how we use the medallion system if you're
Sure,
cool going in that direction.
sure, go for it.
Yeah. Yeah. So the medallion system is an interesting one where, as you kind of said, it's a, full credit to the escape velocity team, Sal and Mahesh, right? They kind of planted the idea and we worked to build something where it works here. But the idea for the medallion system is another cool thing that you can do with tokens versus you couldn't do it without tokens. And the medallion system is a way in which a user can buy 100,000 Dawn tokens and then stake them to mint an NFT that is a medallion. And what happens is when you delegate that medallion to a given market, there's a limit of 3 per market. So like New York City, LA, San Francisco, whatever it is. What happens is the reward multipliers go up. So rather than getting 1 token per household per month, maybe you'll get 2 tokens per household per month. So operators become more incentivized and to deploy in that area. And then what happens is 12% of all transaction fees flow back to the medallion holder. So it's essentially a way in which a medallion holder can use locked capital to steer where the protocol is providing emissions, and then a percentage of revenue flows back towards the underlying medallion holders for them staking the capital. And I think this is kind of came up with an interesting approach where we're trying to think like, we know that to some extent areas like New York should be more incentivized for emissions at the protocol level versus other areas, but we didn't want to be in the scenario where governance is making those decisions. And so we came up with this medallion system where it's like, how can actually the market help decide where the protocol should emit more tokens? And I think that is kind of one model that provides essentially an exposure for, institutional capital to one day be able to get exposure to how the community is actually growing. And I think mechanisms like that, whether it's on our side or in the case of like Daylight's medallion system, I think that the medallion is an abstract enough concept that can be applied to very many DePIN projects with a similar type of approach.
Wow, I haven't heard that deployed that way. That is really interesting. So it basically decentralizes the emission priority, and it decentralizes it in a way completely free of bureaucracy or voting or anything. But it sort of it basically crowdsources your emission prioritization or emission
Correct.
bumping, right?
Yeah, and because when you think about like emissions and like various different types of forms, like not even considering tokens, right? You can consider it from like a monetary perspective, right? If you as a retail investor or an institutional investor, if you want to get exposure to like 3.7 gigahertz, right? Your only option is to go out and buy Verizon stock. But how can you actually find a way to get exposure to what the growth of an individual community is doing in a given area? And I think that is the power of like what a medallion does, is that it allows people to get exposure and help steer emissions in a way that furthers where the community actually goes out and builds, where some level of that growth then flows back to the medallion holder. So I agree, like it's kind of born out of this idea of how do we just be more decentralized and find ourselves doing less. Because I think in the ideal scenario, like we want to build as an organization at the Dawn Foundation, we just want to focus on building a protocol that allows all of these things to naturally form and open source the hardware so people can go build this, right? Like we have a very good pathway towards full maximal decentralization, and stuff like the medallion system is just one piece that actually helps achieve that.
And just so I can explain this again in case people didn't really capture the way I think what you said is, I'm sitting here in Amsterdam today, and I'm like, you know what? I think this Dawn protocol is going to be big, and there's going to be a lot of growth in, I don't know, Scottsdale, and there's no medallions in Scottsdale. So I pay a certain amount. I don't know if that's fixed or not, and I mint a medallion. I lock something up, or I pay. What do I do?
You buy the tokens and then you lock something up. So you
I lock them
stake the
up.
token.
And is that medallion? Is every medallion the same price? Is it bonding curve? How are medallions priced?
Bonding curve, but we're going to have like a couple months to maybe a year where the prices are flat and then slowly increase over time.
And is it bonding curve or whatever per market or just per medallions period?
Per medallions period.
Period. Fine. So I buy a medallion, I lock whatever it is, and I go to Scottsdale, and now everyone who's looking at Dawn is like, oh boy, if I have deployed an antenna in Scottsdale, I get twice as many rewards. So people start chatting. So more antennas start going up in Scottsdale, and then I help drive that. So I'm participating by getting 12% of those emissions.
Exactly.
And which is the same as owning. Sorry, 12%. Yeah.
I was going to say 12% of all of the revenue that flows in Scottsdale.
Fine. Okay. Of the revenue or the emissions, or those both different things?
Just the revenue. So in
not the emissions.
Not the emissions, right? The
emissions are double.
Reserved. Correct.
So I've got to count on that actually being used, like not just built, which helps reduce the gaming of it all. Okay. Fascinating. And then what do you think medallion is going to cost?
So right now we have the initial kind of price at it at 100,000 Dawn tokens. That's kind of the rate that we pick up for the protocol side of stuff. But, we're still kind of finalizing all of the simulations to see what really makes sense.
But that's interesting because you're pricing that in tokens, but it's going to be paid in fiat because it's revenue coming through, not tokens. That's a little interesting piece there. If it was also being paid in emissions, you sort of get it. But okay, anyway, but that's now I grasp it. That's a cool thing because you're really crowdsourcing where the infrastructure, where people think they're not now is where they think the adoption. Now I understand it better. It's where they think adoption is going to be fastest. So maybe where internet is most expensive or people are whatever it is. But fair enough. All right.
Exactly. Yeah, and again, it's like the biggest thing I like to emphasize is like this whole solution for the medallion just came when we're asking ourselves like, how do we avoid reward multipliers being done on a governance side of stuff, right? Like I just want to be able to crowdsource that decision making process.
Well, That's definitely interesting. Let me understand. Paint us the blue picture. How big can Dawn be? How big can this go? Help us understand the scale of this market for people who aren't as familiar. I mean, the bandwidth market is big. Help put some numbers on that.
Yeah, I mean, it's like almost $1 trillion market, right? When you look at it, kind of like all bandwidth telecom services across the world. So it's like an absolutely huge market. I can say, as we kind of think about what the protocol's goal is, the goal of the protocol is to be able to provide coverage to around 265 million households. Funny, oddly specific number, but nothing to worry about there. But the point being is we're kind of focused on these urban dense areas, but there's also kind of rural areas which can be a good footprint. So I'd say like 250 to 300 million households of coverage is kind of what the aim of the protocol is looking to achieve. So based on sort of that level of coverage, is you can kind of work backwards to see like what is the whole potential for internet revenues in that type of scenario. So, but it's absolutely huge when you consider it all across the world. And
But
I think,
let's just pick U.S.
hmm,
300 million people. What is that? 100 million households? I don't even know. You would know. 80
yeah, it's
million?
around a little bit over 100 million households. So
100
I'd
million
say like
households.
our goal in US is a little bit of a different scenario where like in the US, like our goal, like day one, operating on our protocol and other internet providers that we have teamed up to launch this on top of, we're going to have coverage to I think close to 8 million plus households. So I'd say in the US, our goal is to try to get to like the 25 million household worth of coverage here.
Fine. So say 25 million households, and then you would hope that those would have you have some level of adoption.
Correct.
Maybe it's 10%, maybe it's 5%. If it's 10%, less than 10%, say it's 2 million households, those are paying, as you mentioned, I don't know, $30, maybe it's 1 million households or 2 million, whatever, $30 a month. You're talking about 30, 60 million bucks a month going to people, right? Times 12. So you're talking like 100, $200 million worth of revenue. Well, actually more, right? Two to 400 million worth of revenue coming in. And then, um, that's a number of antennas that people then have to be, buying obviously to cover that. Where then does stake and token come into those numbers?
I can't say I've got the simple answer for you on how much of the tokens comes into that, but
Fair
it
enough.
would be
Fair
a good
enough.
a good answer. Like I gotta it'd be good to kind of like get the full breakdown of how much do we anticipate being staked here based on the regions, based on the
But fair
frequencies.
enough. But you give a sense. That's just sort of back of the
Yep.
envelope scale of what we're talking about.
Yeah, and just in the U.S., so
Just in the US.
absolutely, I think it's just such communications is such a big market, and my hope for all of this is just how do we drive all of that revenue said to be into the hands of the household, where like I think we have a very unique opportunity with DePIN both on the telecom side, but also on the cloud side of stuff to really be able to bring that value to the household, where the household is the center of that value capture. So yeah, I'm looking forward to it.
Super cool. Well, any other projects that you like in the deep in space you want to mention or you think are doing something interesting? You mentioned daylight already. Anything else?
Yeah, Daylight is one of. I mean, I love Daylight, right? Jason is probably my favorite founder in crypto, and I'm a little biased, but I've known him for a while. But one of the reasons why I think Daylight is so special, and I talk about this with Jason, is he's one of the only DePIN projects that I've ever seen where the creation of supply doesn't cost the consumer incremental dollars, and that I think is a very unique thing there, where like their ultimate ability to create supply through flexible coverage is consumers' willingness to like tolerate spending less money on like their cooling, for example, right? And if you're in a scenario where like my house at who knows like 74 degrees, right? And you say, okay, but I'm fine if it spikes to 76 degrees, you're creating capacity in the system without actually costing you any money. And that is so unique across DePIN projects where everybody needs to spend money to create supply. But here you can create supply without costing the consumer money, and that puts them in a very unique position. So that's one of the reasons. One of the projects I like is Daylight. The other one, obviously, is just shout out to Witness Chain, right? We're partnered with them on the various proof side of stuff. Like I haven't seen a team that understands crypto economic security better than these guys, and I think they're super well positioned to be kind of at the nexus of so many DePIN projects as they focus on like proofs that are going to be needed towards making DePIN possible, right? Like one of the bigger challenges that we have with DePIN is we need to prove the quality of our supply. And a company like Witness Chain that is really focused on providing those proofs with people all across is just going to be integral for the glue of what makes DePIN focus in the future. And the final one, I'd say a project I've always really loved is like aside from everybody here, like I can talk about how much I like Helium for days, so I'm going to skip that one for now. But then the other one that I'm a big fan of is obviously on the Demo side, right? Like the team at Demo, they have such a creative way of making like that type of data accessible to people, and like I've always been fascinated by the idea of like how can you use the CAN bus in a car to be able to extract meaningful value or provide meaningful value, or make the car better, whether that's like self-driving or in their case data and telemetry. I think it's just a super awesome way to be able to again provide more value to the consumer with stuff that they already own. So yeah, hopefully that's my quick rant on great projects.
Those are great, and it's a good answer, but it's wrong. The answer is Fluence.
Fluence is the other one.
But
yes.
we'll do this again. You'll get the chance to answer it. But again, last question: where do you see Bitcoin? How close are you to Bitcoin? Where do you see Bitcoin by the end of the year? We got a couple months left. We got an election.
So I try to stay away from all these sorts of speculations because I'm more focused on the protocol side of stuff and less interested in the price of this sort of stuff. So Tom, I will respectfully decline to answer that one.
Punted. So, okay. Fair enough. Fair enough. Well, listen, it's been great having you on. How do people find you? How do they find Dawn? How do they participate? How do they buy a antenna? How do they do that? How do they get involved?
Yeah, we've only covered we've glossed over so many details, but the easiest way for people to get involved is, there's my Twitter, @NeilC_Dawn, and then the Dawn Internet Twitter, Dawn Internet is the Twitter handle there. Those are probably the two easiest ways to follow. And, my ask for all of you listeners out there, go out and download the Chrome extension. The Chrome extension has been our way to get the community engaged and start earning rewards on a system. You're essentially using your spare bandwidth to hold people in the network honest and say, hey, I'm providing a gigabit to Tom. How do you know I really have a gigabit? The Chrome validator is operating as this like decentralized cloud of excess bandwidth or challenging this connection that I'm providing Tom, for example. So I hope you kind of get involved there and get involved with the Chrome extension as a way to be able to start earning rewards on the system and be able to provide excess bandwidth to people.
Well, listen, Neil, I know there's so much more to cover. We haven't had a chance, and telco is a love of mine. I started off being a telco in the banking side quite a while ago. So there's so much more to go into. So we're gonna have to do an update once in another couple of months when we can talk about traction, case studies, what's gone right, what's gone wrong, and I can't wait to do that. But thanks again for being on, and I hope everyone finds you.
Yeah, thanks again for having me on, Tom, and I appreciate the conversation. Catch you guys all later.
Great. Thanks so much. Bye.
See you, man. Bye.
All right.